Good morning, everybody. It's 10:47, so I suppose I'll get started. I'm super excited to be able to present in front of you today. It's great to see so many people interested in building some simple, energy-efficient walls. So, a quick agenda of what I'll be going over. I'll be talking about some industry trends, give a quick overview of our product, some of our best sellers, take a look at some of the projects we've done, answer some FAQ, and I'll open the floor up to you guys. So, with that, let's just jump right into it. So when it comes to improving our buildings, a lot of times we focus on the interior, making them safe, comfortable, and healthy. Whether that's smart home systems that puts the control of our homes at our fingertips, or net zero homes, which let us live more healthily through improved indoor air quality and lowers our monthly up cost. And on the surface, this focus on the interior makes sense. It's where we spend all of our time. But it's come at the cost of neglecting our exteriors. And now more than ever, we need to re-examine them. Canadians want energy-efficient homes. This is from a poll done by the CHVA in 2021, asking respondents if they support net zero-ready building codes. And Canadians overwhelmingly said yes. 70% said they support or strongly support these building codes, with the most support being in Ontario and Quebec, and the least in Alberta. Surprise, surprise. But even in Alberta, 60% said they either support or strongly support these building codes. So with consumer preferences pointing this way, the government pushing towards energy efficiency, and industry and market trends all pointing towards energy efficiency, now more than ever, builders need to know their options of how to meet these standards. And that's where we come in. SIS panels are a lineup of exterior insulated sheathing for the building envelope. By laminating several different layers of the building envelope into one product, builders can streamline energy-efficient construction and reduce labor costs across the job site. It's a big value to be able to build better without changing your processes. We really believe that the more easily integratable a solution is, the more widely used it can become. Our CEO, Frank Hassan, he has 45 years of manufacturing, home building, and prefab experience. We're currently in the process of getting our CCMC done, and they actually have a record of our product being used on some of the first R2000 homes done in Winnipeg during the early 80s, which Frank worked on. That's where this was born. So it just goes to show, it's not a complex or new solution, but now there's a need for it. So now let's look at a couple of our products to give you an idea of what exterior insulated sheathing builders are currently using. As I just mentioned, our one-sided OSB SIS panel. This is our best-selling solution in Alberta. We find builders gravitate towards it when they're looking to dip their toes into building better. Like I said, uses familiar materials. It's easy to wrap their head around. Sterling Homes and Brookfield Residential have both written this product into their net zero programs, which is something we're really excited about. They love how easy it is to work with, and like I said, they can build better without changing how they build or the speed they build at. This is also available with fire-rated OSB, which we code in-house. So this is perfect for areas that require fire-rated sidewalls. Next is our plywood SIS panel. I won't spend too much time on this because it's pretty similar to our OSB, but we see a lot more interest for it here in BC compared to Alberta, which is interesting, especially when paired with a mineral wool insulative core because of its non-combustibility and eco-friendly properties. Next is our one-sided dense glass SIS panel. This has been the most popular of all the exterior drywalls, however we work with all of them. Brookfield Residential is looking at using this with a mineral wool insulative core to give their sidewalls a 1-hour fire rating, which is something we're really excited about and currently pursuing with them to it. Last product I'll highlight is our MgO or magnesium oxide SIS panel. This is definitely our Cadillac of solutions. We really believe that magnesium oxide has a big future in the building world. It's non-combustible. Adding it into your assembly will give it a 2-hour fire rating, taking into account the interior drywall and other components of the assembly. It's eco-friendly. If you took out the fiberglass mesh from within it, you could eat the board if you really wanted to. It's pest-proof, water-resistant, and it's structural, meaning your cladding systems can be installed directly into the board. No need to install to the stud. This has been our best seller when it comes to commercial and multifamily projects. So this is a burn test we did with the MgO SIS panel using a phenolic core, both non-combustible materials, because we believe this will be a great solution in areas that experience wildfires, because if a building frame can remain, they don't at least have to start from square one every single time. I'll show you some temperature statistics in just a moment, but the MgO performed quite well. After pointing a tiger torch at it for just over an hour, the boring performed great. There was no damage to the building frame, and even the adjacent panel showed no signs of damage. With how easily replaceable these are, if a wildfire were to come through, it's a great solution for having your community survive. So these are the temperature statistics I mentioned a moment ago. The front of the panel reached a max temperature of 1,141 degrees Celsius, and the back only 69 degrees Celsius, a 94% difference. It was pretty crazy to be able to touch the back of the panel after doing that test. So while this is just a demonstrative test, we're currently in talks with Intertech to get the actual testing done. But we're a big fan of seeing is believing. So the first question, which we get a lot, do you make SIPs? In fact, sometimes people don't even ask. They just kind of assume. And honestly, I don't really blame them. Looking at the two products, they look virtually the same. So I'll highlight three quick differences between our SAS panels and SIP walls. The first is how they're used in the wall assembly. A SIP wall is the entirety of your wall structure, usually consisting of a 2x6 stud, EPS insulation, and OSB sheeting with pre-cut channels in the EPS for your utilities, wiring, piping, etc. Whereas our SAS panels are an insulated sheathing installed to the exterior of your building envelope, so nothing changes for repairs, inspections, or renovations. Whereas with a SIP wall, the inspector might have to literally cut a hole in the wall to see what's inside of it. Next is the customizability, as I've talked about. With SIP walls, really you don't have a lot of options. Some suppliers do use magnesium oxide or different insulative cores, but these are more of outliers. So that's why the SIP market is really not a big part of the housing industry as a whole, we believe. That's why we focus on servicing 90% of the housing industry, not that 3% of SIPs. Next is how they're installed. I always tell people, if the marketing guy, can install these, any tradesperson can. They're installed just like regular OSB, no special tools, training, or trades required. Like I said, we really believe that the easier it is to implement into their building process and into the wall assembly, the more widely used it becomes. With SIP walls, because of the pre-cut channels, they're much more complex by nature, and the margin for error is much higher. Ultimately, they're only as good as their installers. And it might sound like I'm putting down SIPs with this comparison, but that's honestly not the case. We really considered making SIPs ourselves, but we have the expertise and equipment to do so, but it's really just not our cup of tea. Like our CFO, she lives in a SIP house and complements its energy efficiency all the time. One comment she makes that really stands out to me is that sometimes she turns up her thermostat just to see if the furnace still works and how infrequently it turns on. But like I said, even that product's only as good as their installers. She talks about how when the product first arrived on the job site, it had big arrows on the wall showing which side goes up. Pretty self-explanatory, but several walls were put on upside down. So this resulted in not a snug fit. The windows are way closer to the ground than they should, and all the channels had to be cut on job site to account for that error. So like I said, let the SIP world fight for that 3% of the market. We'll focus on the 97% that does traditional builds. Speaking of traditional builds, this is a quick comparison video we did comparing building a traditional wall section to one with our SAS panels. The only difference is using standard OSB versus our OSB SIS panel. You'll see that it takes no extra time to build a better thermally sound wall. A small difference of using a different product can make a huge difference in the thermal performance of your assembly. You'll see that our team actually ended up building our wall a little bit faster than the typical wall, but that's just because of how familiar we are with our product, which I would hope. So next piece of FAQ. How do you recommend wrapping the corners with SIS panels? So the goal with all our insulated sheathing is to have a closed system. As leaving it open, like you can see on the right, leaves your wall open for moisture to enter through the wall and then the frame. By keeping the system closed, to keep the system closed, we recommend trimming one of your insulated sheathings. So that way you can create a snug butt joint that creates a tight external fit, ensuring no airflow or moisture can enter through the wall. Is thermal bridging really a big deal? I've mentioned thermal bridging a number of times now, and we'll be the first ones to tell you the building industry has known about it for decades and decades. If it hasn't really been dealt with, is it really that much of a problem? Well, first a quick definition. Thermal bridging, what is it? So a thermal break occurs when there's a thermal break in your building envelope, most commonly with studs with and studs that interrupt cavity insulation. Heat will always escape through the point of least resistance, and in your wall, that's exterior studs. There's a couple different ways to deal with it. Your standard wall, no real protection from this heat loss. And it can also cause condensation to enter your wall as the warm air from inside meets the cold air from outside. Wrapping your wall in a layer of continuous exterior insulation, whether that's with our product or just rigid boards, will stop this from happening. Alternatively, there's also advanced framing techniques like double stud walls or a staggered stud system, which definitely work. However, they take a bit more time to install, more costly due to the material. You end up sacrificing interior space. So we believe that continuous exterior insulation is a better solution to fixing this problem. Well, so what? Well, I'll quickly go through an example case study to show you exactly what thermal bridging will do to your wall assembly. So this is a standard home, 2,000 square feet, R22 exterior walls, 2 stories, no garage. Doing the math, you find this home has 260 linear feet of total exterior wall space. Keep this number in mind because we'll use it in a couple slides. So to calculate thermal bridging, we next need to find how much of the wall space is taken up by your studs and plate material, because those will be your 2 biggest contenders of heat loss by thermal bridging. So doing the math and adding them together, we find that we have just under 45 linear feet of exterior wall space exposed to heat loss. Taking that with that 260 number we just talked about, that's 17% of your exterior wall with essentially no insulation. This is a 2-scale drawing, and that red wall at the bottom is all of the studs and plate material put together. So that's how much of your home essentially has an R value of R5, R6. When we first crunched this and did these numbers and discovered this honestly blew me away. People are buying premium energy efficient homes where this isn't really addressed or not fully addressed. And like I said earlier, net zero home has 3 components: mechanical system, renewable energy system, and the building envelope. And the 3 operate in tandem. Having one be less than the others will just bring down the whole thing. I think of it like buying a winter jacket with holes in the exterior. I don't really care how good those interior layers are if there's holes in the exterior. But a better building envelope will help your mechanical system by limiting how hard it must work and how often it must work, which can extend its lifespan. Or even, maybe you don't need that highest efficiency furnace. Maybe you can down a peg or 2, save some costs. With your renewable energy system, if your home requires less overall power to heat, the renewable energy system has to work that much less harder. So we really believe that while all these are important pieces of the puzzle, the building envelope needs more attention. So that's why we're so focused on education. We find that once we explain the facts to people and how our insulated sheathing fits into the puzzle, slowly the dots start to connect. Then when we give them stats like this, maybe now they're considering taking the plunge into improving their building envelope. Why wouldn't you invest in something that actively increases your property value, lowers your monthly bills, and lets you live more healthily? So to wrap up, we know there's going to be a huge need for energy efficient solutions in the near future. We've heard down the grapevine that exterior insulation could become mandatory in the future, which we've already seen in some areas of the US. So when that and other net zero changes become more solidified, there's going to be a huge rush of builders to meet these standards. Right now, only a small portion builds to these standards. The CHBA has already identified one key pain point of these changes will be a lack of energy advisors and other qualified officials. So when these changes do come, it's going to be a mad rush. That's why we're here today trying to educate builders about the options that are available to them, whether they choose to build to these standards now or are forced to in the future. Thank you so much for listening to my presentation, and I encourage you to scan the QR code to leave some feedback.